today's special guest is Key2Act team, and we are really pleased to have them on this webinar. We have three team members of Key2Act today, which I will introduce shortly. Thank you for being here, everyone. To just get started, just a review of what we do here at Bit9 and what Agents Graph can offer you really quickly. So as you know that Bit9 introduced the Agents Graph, and Agents Graph is a multi-model graph database which can give you the ability to model in a different basically structure. So in Agents Graph, you can have your data in a relational model, also in a graph model. Also, Agents Graph supports key value and also document structure as well. So our teams are in a different part of the world. We are located in San Francisco. We have a team in New York, London, and Seoul, South Korea. So we are global and we are growing fast. To give you a little bit background of what Agents Graph can offer you and why Agents Graph can be a good solution to your use case or to your problem, as I mentioned, Agents Graph is a multi-model database. And by saying that, it means that you can have your data at the same storage, but in a different structure and different model. So, and by having this, Agents Graph will give you the capability of writing hybrid queries. And when I say hybrid queries, it means that if you have, let's say, relational data, and if you have graph data at the same storage in Agents Graph, you can write the query, which is a combination of both languages, SQL, and also Cypher, which is a graph query language, in the same query. And you can run that query and fetch your data from both models. So if you want to take a look at it in more details, let's assume that we have two models here. We have relational and we have graph data. So by saying that, you can write a hybrid query this way. You can have Cypher and SQL. So as you can see, you can have Cypher query as your inner query and SQL query as your outer query. And by doing this, you can fetch your data from both models. Or you can have it the opposite way. You can have SQL in Cypher, so you can have your SQL as an inner query and Cypher as your outer query and access your data. And also at the same time, it's really easy to ingest and import your data in Agents Graph. You can simply use Agents Graph FDW, which will give you the capability of having your data in Agents Graph from different sources. It can be a web data, it can be file data from different databases, and also from any, as I mentioned, big data. Now, what I also wanted to mention is that after you importing your data in Agents Graph, you can use the graph analytic tools that we have. You can use our graph algorithm, anything that is in your is more related to your use case, and you can also use our visualization tool, which works with Agents Graph, and you can visualize your data, analyze it, and basically see it over there. So this is really high level of what Agents Graph can offer you, but if you have any question, you can always send us any question that you have. And also some of the news, one of the good news that we have is that Agents Graph was chosen and was announced as one of the 4 top multi-model databases management system technology by IDC. So IDC, some of you might know, but if you don't know, it stands for the International Data Corporation. And what is IDC? IDC is an American provider of market intelligence, advisory, and events for the information technology. So they always, report some of the technologies that are there. So, and in their latest report about multi-model databases, Agents Graph was chosen as a top 4 databases. So if you're interested, the report is in this link. You can just click and read it. There are more information about our product, Agents Graph and Bit9. And if you have any question, again, you can get back to us. So as I mentioned, our today's special guest is Key2Act team. We have three speakers and team member of Key2Act, which we are really pleased to have them. We have Justin Tasker, the product manager. We have John Abbott, senior application developer, and we have Dante Gabrielli, the CTO of Key2Act. So before I hand it to the Key2Act, so they can continue with their great webinar that they prepared for us, I just want to mention that the chat channel is open. So if you guys have any question at any moment, you're more than welcome to send the question through the chat. We will receive it, and at the end of the webinar, we will start answering your question. So thank you again for joining. Key2Act team, thank you for being here. Hope you're all doing great.
Thanks, Aya. This is Justin Tasker, the product manager for Key2Act. We'll do a couple introductions here down the line. John, Dante, if you want to introduce yourselves as well.
Sure. I'm John Abbott, and I'm a software developer for Key2Act.
And I'm Dante Gabrielli, the Chief Technology Officer at Key2Act.
Go on to the next slide here. Hey, it's hanging up a bit here. Here we go. So a quick high-level agenda here. We're going to go through an introduction for Key2Act itself. We're going to talk through what a smart building is, and we're also going to give you some insight into like the industry that we are operating out of. It's a less commonly known industry called the building automation system industry. Give a bigger picture of the ecosystem in general, that smart building ecosystem that we were talking about in the introduction here, and then we'll give you a look into what our role, Key2Act's role, is in that ecosystem. And then we'll open it up for some questions. If there are some questions you've sent into the webinar here, we'll be able to answer some of those questions as we move on.
All right, so again, my name is Dante Gabrielli, Chief Technology Officer here at Key2Act, and just want to give you a breakdown of who we are and what we do. So Key2Act was actually established as a company called Wensoft back in 1995. Wensoft was a company that was heavily focused on field service management, project management, all through integrated accounting in an ERP system. We're actually now through acquisition, Key2Act. So we're the merger of actually two different companies here. So as Key2Act's been around for about 5 years now, and we have over 600 customers worldwide. And we have a heavy focus on mechanical service providers. Mechanical service providers being those companies that focus heavily on services like inside of buildings for HVAC equipment, lighting, building automation systems. So again, you can see what we do really focuses on buildings, which is why we're here talking today about the smart building ecosystem. One of the key things that we do also is we leverage those building automation systems as points of data that can be transmitted and sent to the cloud for analysis, giving us good insight into the health of buildings. So yeah, any questions that you guys have at any point, please let us know. But yeah, that's who Key2Act is.
Thanks. So first I want to give you some background on building automation systems. And what I'm going to do here is I'm going to relate this kind of back to another industry that you may be more familiar with, and that's home automation systems. And when I talk about home automation systems, you may, what comes to mind is Amazon's Alexa or the Echo, Google Home, HomeKit from Apple, those types of things. And you've got individual light switches or bulbs, or even your thermostat may be tied in with Alexa or something like that. That's a base sort of representation of what a building automation system is. So the home automation sphere, there's some key differences between that and building automation. One is, most of the stuff you're dealing with is wireless. You've got a central hub that communicates out to the cloud, and they're doing something with the data in the background, whether they're listening to your conversations or storing, when you turn your lights on, what set points you like to set your heating and cooling for your air conditioning as well. Building automation systems are very similar in that regard, in that there is a network of different devices out within these commercial or government buildings. A key difference here is that we're primarily dealing with, or our customers are primarily dealing with, hardwired networks. So while the industry has moved towards IP-based controllers, where you're dealing with Cat5, Cat6, Ethernet cables for communication, a lot of our customers have installs where they're using a serial connection, like a two-wire connection between these things, and they're daisy chained in line. So you don't have all of these efficiencies. In a lot of ways, home automation is a little bit ahead of building automation systems. You're also dealing with automation at a much larger scale. So where you may have 10 or 20 devices within a home, you may have upwards of thousands of devices within a commercial office building, or a high rise or dormitory or something like that. Then you're talking about tens of thousands, if not hundreds of thousands, of data points that are coming out of those systems. Another key difference with building automation versus your typical IoT solution is that the data model is driven primarily by whatever that installer decides he wants to name things. So when you've got a thermostat within your house that's putting out space temperature, or whether or not the fan is on or something like that, they know coming out of that system that those things are well defined. When you're dealing with building automation systems, those lighting contacts or the heating and ventilation for the building, all of those naming conventions are what dictates what those things are coming out of the system. So the system itself, you go to 100 different installers, they're going to have 100 different standards of naming those things. And even within the same contractor themselves, they may have two identical units sitting next to each other, two identical pieces of equipment sitting next to each other that are named differently. So you have no way on a cloud type solution to understand that these things are the exact same. There's also typically no learning opportunities. So we talk about, home automation again being all tied to the cloud, and Google, Amazon, Apple, they're all doing analysis on the data that's coming out of the system to start suggesting, hey, these are the patterns that we're seeing across our customer base. They might be applicable to you. And they can even start solving problems that are not even identified as problems by their user base yet. With building automation system, each automation system is typically its own standalone installation. So it has no ability to communicate with those other systems or to learn from those other systems. They're also programmed to do something. So the installers themselves are programming these systems to do a certain set of things. And if anything happens outside of the realm of what it's been programmed to do, the building automation systems just continue on with their path. So if something gets overridden, meaning somebody had decided, a human has decided that something else should happen, the building automation system just keeps going and says, that human decided this is what I should do. That's what I'm going to continue to do. I'm going to quickly define something of a definition for what makes something smart, and we'll use the Merriam-Webster definition. So Merriam-Webster defines intelligence as the ability to learn or understand or to deal with new or trying situations. Also, the ability to apply knowledge to manipulate one's environment or to think abstractly as is measured by objective criteria. In other words, the ability to learn, understand, to see something, or to learn from something that has happened elsewhere before. Humans are a lot like this in that a lot of our decision making process is based on situations that we've encountered elsewhere. In that, with that in mind, our definition of smart, or definition of intelligence, when as it relates to the smart building, is not necessarily just the ability to connect up to the cloud and send your data out, because as it stands today, a lot of our buildings do have that ability to offer up a connection out and harvest that data in some form or another. But what they don't have is the ability to interpret that data and say, well, you know what, based on, let's say there's a building out in Florida, it's very humid, we require a lot of air conditioning. I've encountered this problem before, or a very similar building has encountered this problem before, and here was the solution to it. So then the system can then adapt and say, based on those criteria, this is most likely the cause here, and be able to then make a decision based on that. So when we talk about, I sort of kind of jumped ahead of the presentation a bit here, but we talk about what truly makes a smart building. Again, it has nothing to do with necessarily being able to get data out of the system, because that's just one small piece of the puzzle. It's really what is the system doing with that data once it's been harvested, right? Is it able to learn from another similar situation? Is it able to adjust or adapt to what has happened in other buildings or other situations? And right now, that's almost an impossibility, because there's no standardization across the industry. Even like I said, across individual installers, you may have no standard, and they're not networked together via anything. So you see a lot of, and we position ourselves again this way, is we're able to pull that data out. But what we need to be able to do is we need to be able to understand what has happened or what's going on with this subset of things within buildings, so that we can help the buildings make decisions based on those criteria. And even if we can't help the building make a decision, what we can do is we can help inform the people who are going to fix those things within the building. So we talk about the mechanical service providers, and those are our primary customers, but being able to help them understand that this has happened in other places before, and here was the solution, can help get that resolved. I'll tie that back to it may be a little more relatable to tie it back to, your home heating and ventilation. So in your home, you may have an air conditioner or a furnace for heating. And if you have a problem with your HVAC system at home, typically what you do is you call up a service provider and you say, hey, I'm having these problems, or this is the noise the fan is making, or something like that, and you describe it to them. They'll get you on the schedule, they'll send a technician out, and they'll come out to diagnose the problem. And most likely you're getting charged for that diagnosis fee unless you've got some sort of service contract. When they diagnose the problem, they may need a part or something like that. And when they get on site, there's no guarantee that they're going to have that part. So they may need to go out and order it, or go to a warehouse and get it. And you may be without service for a day or 2 days, maybe even up to a week if it's a specialized part or something. What we would like to get to, or what, as it relates to a truly intelligent or smart building, is if that service provider, when you call them, could understand, here based on historical data, I understand what the problem is. I've got 3 of those parts in my warehouse. I'll make sure it's on the truck with our technician before they head out. So they're doing that just-in-time service with the right parts and solving that problem, because they've been informed by all of that data coming out of the system. And even thinking a little bit further on because that data is becoming so readily available, being able to understand that this looks like it's going to be a problem and start proactively addressing those problems before a customer needs to actually call in and say they're having a problem. So really getting out ahead of the problem themselves, and understanding that this has led to a problem in 90% of situations or something like that. Would you like us to fix it before it becomes a problem? And that's just a conversation that our customers can start having with their customers, because of the amount of data and analysis that we're doing in our cloud.
Yeah, Justin, I think that one of the things that you see is everyone's so quick to define something as smart, in particular as it relates to the building automation industry, because it's quote unquote digital, right? So if you're not familiar with the building automation industry, 20 years ago, everything was pneumatic, right? So there were air compressors that were down inside of mechanical rooms, and that was what was actually being used to drive control and sense what was happening within a building. And buildings are 20, 30, 50, hundreds of years old. And the way the industry has sort of positioned itself is, wow, we put in digital control and therefore the building's smart. But to your point earlier, Justin, around buildings being smart requires a little bit more than just, hey, I can now hook up to the internet, or I'm using, digital approaches versus old school analog approaches, right? So you mentioned the point that building automation systems are currently pre-programmed to accomplish a sequence of operation that's put into place by some design engineer. But when we really start to understand what makes something intelligent, is this ability to recall, what's happened in the past, learn from other people or buildings or whatever it may be, and it's this ability to adapt and grow. So we talk all the time, with other colleagues of ours, or even internally, where we say for something to be intelligent, let's compare that to human growth, right? So A child, as they're growing up, doesn't just, be considered smart because they're alive. It's as they continue to learn, as they continue to learn from the situations that they're in, they gain knowledge and wisdom over time and have this ability to now act out of that background and understanding. So, for example, if I stub my toe walking in the dark, I know next time if I would put a light on so that I don't make that happen. Or if my stomach hurts and I know that I got sick, I want to make sure next time I go ahead and rest. And that's the key thing for us is as we sit here and look at it, buildings to be intelligent should be able to learn from other buildings. Just like a child goes to his dad or goes to school or goes wherever he needs to go, he can learn from these individuals about what they've gone through so that they don't make the same mistakes. So if you drive that analogy over to a building, when buildings are built or when buildings come online and become, more digitized, they should have the ability to reach out to another building with a similar set of, context, right? Where am I located within the world? What are the types of weather conditions that I'm experiencing? What type of equipment do I have in the building? What's the purpose of this building? Am I in healthcare? Am I a data center? Am I a multi-tenant office building? And by understanding things in that context, it could reach out to people or buildings, I should say, that are constructed similarly, configured similarly, and understand that, hey, when this design day was hit, what did you do? How did you respond? And were you able to get your building back up to temperature? Or were you not able to get there? How long did it take for you to get there? And if you can use that information to learn from these other buildings and know that if it's going to be a 105-degree day, I may need to run 2 chillers, and that'll keep everybody from getting warm, and my building will operate as it's supposed to. That's the way that a smart building or an intelligent building should operate. Currently, today, when that happens, you've got some, boiler operator or plant operator going out and making those changes on their own. The building itself should be able to adapt and adjust, especially for the amount of money that people invest into these buildings. There's tens of thousands of sensors, and that's great feedback on what's occurring. Now, let's use that information to intelligently adapt the building to its evolution over time. And also, to your point, it's most service calls are driven by an effect that's occurred in the building, right? I am hot, I am cold. This operating room can't be used because the air pressure is not in a spot to allow for the contamination of other spaces through infectious disease that could be sitting within the air. So there are typically things that are occurring before that happens. The compressor starts to short cycle, or there's no hot water coming from the boiler, or name your different problem. If you can anticipate the experience of the building occupant through looking at what's occurring inside the space or inside the piece of equipment, you can actually get that fixed before there's a bad experience. So what we want to do is position service providers to receive service calls on behalf of the building via software and things like that, versus waiting for the problem to be experienced by the end user so that they have a bad experience.
So we talked about the buildings a little bit here. We talked about building automation systems in general. What we'd like to do also is talk about the broader ecosystem, if you will. We mentioned that mechanical service providers are primarily our key customer here, but there are a number of different types of service providers who also would benefit from this type of solution. There's energy services companies, which they're primarily dealing with some sort of agreement with a building owner or corporation or something in general, where they're tasked with reducing energy use. There's a lot of government initiatives that say you must reduce your energy spend by X amount. So there's companies that primarily deal with just the energy side of that, whether that's replacing equipment or changing those sequences that have been programmed. There's also professional services organizations, or PSOs, which deal with commissioning, which means making sure that building is operating as it was supposed to, as it was designed by those design engineers. And all of those different systems, those different service providers have different operating software within there that allow them to do business from a day-to-day perspective. It's got their accounting software, they've got their sales management software, they've got their service management software, meaning like where are my technicians, who's scheduled to do what work orders are they working on. So they've got all these different tracking systems in place, as well as the accounting to operate their business in a day-to-day. That is all part of that overall ecosystem that ties in with everything that has to do with managing a building or servicing a building. So yes, you have that building data, which helps you inform and make decisions on what's going on within the building. But you've also got these software systems that, you know, they help manage the system, and those are part of the overall ecosystem as well. And each one of these different service providers, while they may use similar software, the manufacturer of the software, the vendor of the software may be the same within organizations, but they're leveraging them in a unique situation. So our product needs to be flexible for those organizations. And what we want to make sure is that when we build out everything that we do within this platform, is that our software adapts to those already established workflows, and we're not pulling those companies out of their workflow, their established workflow, to use our solution as well. Just a quick quote on buildings in general, just to give you sort of an order of magnitude of where we are right now. The smart building market is currently around $60 billion in revenue, and it's going to expand exponentially over the next 5-6 years as well. So we're primarily dealing with comfort and energy, but there are initiatives to start pulling in more of like the access control, security systems, the video monitoring within the systems, as well as life safety, the fire alarm systems, for instance. If it's a garage or something where there's vehicles, carbon monoxide, those types of things that are, sort of becoming commonplace within your home are now starting to be networked together, or there's requirements to start doing with all these things. So the solution that we have needs to be scalable with that amount of data. We need to make sure that while we're pulling hundreds of millions of data points out of buildings currently, that's just going to keep increasing. So we need our system to be, while it's true cloud, it needs to be scalable with the industry in general. So we just pull in our solution here, the building optimization broker. So here's where we fit within that ecosystem. We talked about buildings, we talked about those business systems. The optimization broker is really in place to help facilitate that exchange of data between the systems. Currently, what you have right now is you've got analytics solutions, which will take that building automation data, do some analysis on it, spit out a report that's really like, here's a punch list of things that need to be fixed within the building, or here's what's going on within the building. Then you've got to manually hand that information over to the service management department, or the dispatchers, who are the people that are sending technicians out to the sites to fix the issues. And that manual exchange of data is usually where a process breaks down, or people make mistakes, or they just they don't do part of that process. So you get this roadblock in adoption and really success, if you will, of this analysis from all the building data, because you're requiring people to adhere to an operating procedure which says, I need to hand this information off. So optimization broker is really in place there, again, to facilitate that exchange of data, to broker, if you will, that exchange of data between systems. How do we do it? There's a number of different applications built into the platform itself. We've got IoT Hub, Architect, Rule Builder, and Home, and they have 4 distinct responsibilities within the platform itself. IoT Hub's all about getting data out of systems. So whether that's the building itself or one of the business systems that they're using to manage their day-to-day, IoT Hub is where you would pull that data out of those systems. The next bit is normalization, and data normalization is incredibly useful. I mean, it's pivotal to the success of our platform in general. And this is really where we tie in that graph technology, because as soon as you pull in more than one data source, you need some sort of normalized model. So we are taking data from the buildings, those business systems, and we're making relationships between those things. And they're not necessarily always parent-child relationships. We're able to take it and again, leveraging that graph technology, and start branding, or making the nomenclature common, and saying that this piece of equipment has ties or serves multiple areas in the building. This piece of equipment is part of or is associated with a system that serves another purpose. So we're able to allow our customers to work like they talk. That's how we've pitched this normalization exercise here. And they're not dealing with like this data coming out of the building has to be done, on this device. We're talking about this piece of equipment has a problem, or show me all of the problems I have with a particular piece of equipment in buildings in Texas or another area of the world. So that normalization, again, is ultra important as we get into pulling data from these different pieces. So as we integrate to more and more data sources, we need to normalize that data so that you can actually do something with it. And that takes us to the next step here, which is automation. So all of that data is great, but until you can, in an efficient manner, do something with it, it's just data overload. So we've got an application called Rule Builder, which is there's an entire rules engine behind it, but this is where we are allowing our users to build, or we built our own rules that say, hey, look for these different criteria within all of that data, and should you find an exception or something like that, start doing something with it. So whether that's create a service request, whether that's just, hey, send an email or a text message to somebody. There's a lot of flexibility with what you can do within here, but again, having all of that data, normalized data, is incredibly useful, but it's less useful if you don't have some machine that can sift through all of that noise and really give you actionable intelligence from the system. The last piece of the puzzle here is visualization. So you need some sort of visual indicator that shows you here's what's going on within the building. So we have an application called Home, which kind of displays some of that information for the users after they've gone through these 3 other steps, if you will. What do these things look like? What's going on with those in these buildings? Where should I prioritize my time on site? Or if I've got some guy going out already to look at something, got a technician already scheduled to be there, is there something else they could look at while they're on site, because we know that there's something going on with this piece of equipment based on the rules that our users have configured. And all of this is powered by AWS. So again, it's a full cloud solution. While we do have a distributed method of getting data out of buildings, everything we're doing from an integration, normalization, automation, and visualization perspective is all cloud-based. Just quickly talking about the why here. So we talked about all these different systems, these disparate systems, I should say, within the buildings and the service providers as well. We really wanted to start bridging that gap. We want to end the fragmentation between the systems. Like I said, there's a lot of barriers to adoption or success within an analytics solution like this, because there's nothing talks to anything. You may have 3, 4, 5 different softwares within an organization plus the building, which are, and they're all managed by different verticals within the business. So different business units typically administer their own software, and they're subject matter experts within their own vertical, but none of them have this common language to communicate with each other. So that's why the optimization broker helps facilitate that exchange and ends that fragmentation within the organizations. We wanted to learn from lessons. Those are industry lessons. There's been a value proposition for analytics-based service for years and years now, but delivery on those promises haven't been, have been sort of intermediate, if you will. You can do some things, but they require subject matter experts. They require high value technicians or engineers to manage the solution and to really get those deliveries that have been promised. So we're learning again from ourselves and our industries as well. We do have those 2 sides of the business. As Dante mentioned, we're a merger of 2 acquisitions. We've got the business application side, the accounting side, if you will, and then we've got that building data side. And we're trying to learn from what we've done from both of those individual pieces of software and start merging them together to really build out this optimization broker that really ties in with delivery on our vision as well, which is improved service through technology. And really, because of those other steps along the process, this will, as we feel, allow us to fully deliver on that promise as well. So at this point, I guess I'll turn it back over to you. I don't see a lot of questions coming in right now, but.
Of course, yes, thank you. Thank you, KTAC team, and thank you, Justin. So just quickly, let me make sure. So right now we don't have any questions, but I mean we have time. So please, if you have any question, just send it to us, so we can give it a couple minutes to receive the question. And at the same time, until we're waiting for maybe any possible question, I just want to mention that even if you have any question later on for Agents Graph team or Key2Act team, you are more than welcome to connect to us and send us any question or any consulting that you need. And you can just simply go on our bit9.net website or on Key2Act and connect to us. After this webinar, I will also share some materials and our contact information. So if you're interested, you can join us. So just one more time, I think you can, if you have any question, you can just send it through the chat channel, and then we'll be able to answer that.
Hey, we did have a question
Justin.
come in. Thanks, Dante. We had a question come in that said, you know, what is our method of data collection? I'm going to assume we're talking about building automation systems in general, but maybe also the software suites. So we have a device, and we also have software that can be run locally that will connect up to the building automation system. And we connect to, there's a central controller typically that is IP based, and we'll connect via one of a few different IP protocols. They're industry specific, so pseudo industry specific. There's a protocol called OBIX, and then there's a protocol called BACnet. So we connect up to that building controller typically, and we request data from the system, and then we ship it up to the cloud.
Okay, perfect. Thank you. And we have one question from our side. Can Agents Graph automatically generate graph nodes by importing SQL data? So if I get the question right, the question is asking that if we have like relational data in a table format, and we wanted to create the graph model, would that be automatic? So the answer is like yes or no. It's not, the whole process is not completely automatic, but you can write some queries, and you can basically model your relational data in a graph format. So I hope I answered the question. If not, I can get back to you with some examples on this question. Okay, so I believe it looks like we don't have any questions. So give me 1 second. So I think, Justin, you have a question in continuous to the previous.
Yeah, I see combination of physical device. Yeah, so we do have physical devices, and we have an upcoming software version which allows us to connect up to distributed systems as well. And from a software side, from the accounting side, if you will, that would be more of a software deployment than a physical device.
Okay, so I believe these are the questions for today. So again, please send us any questions that you have, and we'll be more than happy to answer your questions. I hope you all enjoyed this webinar. We recorded this webinar, so after preparing it, it will be ready to watch, and we'll be sending it to you, and it will be available on our YouTube channel as well. Thank you again all, and have a great day. Thank you, Key2Act team.
Thank you.